So what is CycloneDX? If you look at like a bill of material, or if you look at the spec from like the top down, what does it do? Well, the very first part is just about the metadata itself, right? What is the bill of material? What is it describing? What software, what service is it describing? Who is the manufacturer? Who is the supplier of those services? What tools were used to create the bill of material? That sort of thing is really in the metadata section. Um, the components and services, that's really the heart of your inventory. So what are the hardware components? What are the software components? What is the inventory of those, including any, pedigree, like all the modifications thereof, all the assemblies, like a component, including other components. All that kind of metadata about that inventory is captured in components. Likewise, services is a equal, um, you know, inventory type within the bill of material format. Services are really important, but we capture the endpoint URIs, the data classifications, directional flow of data to and from different things, who the providers are, all kinds of information about the services. There's enough information on services so that you could actually create the basis of a threat model. That was really the intent on the services support. Um, and services really are important for things like mobile apps, which don't usually, run self-contained, right? They usually fetch things off the internet or, whatever. But yeah, it's really important feature of the bill of materials form. Of course, the dependency relationships, that's a section of the bill of material format that we can capture, what components rely on other components, or, what services depend on other services, and kind of mixing and matching those as well. We capture the entire dependency graph, so you can specify what the direct dependencies are, what the transitive dependencies are, that sort of thing. Compositions are really important, and this actually came about. Cyclone really came about in, it started before this NTIA effort, but this was one of the features where NTIA and their work really influenced, I think, some of the spec. Compositions is really the idea of being able to capture completeness, right? How complete is my inventory? How complete is my assembly, or subassembly of my inventory? How complete is my services? How complete is my you know relationships? Um, and being able to describe, hey, this thing is 100% complete, or I'm only describing maybe the first party components, or maybe I'm only describing the third party component inventory, or maybe I really don't know what's in this thing, right? Maybe I got a library from a commercial vendor, and I honestly don't know what's in there. But being able to describe that is part of the spec. Of course, vulnerabilities are also part of the spec. Vulnerabilities can also be inventory. We support a bill of vulnerability use case, where if you want to trade vulnerability information between different systems, perfectly valid use case. Don't have to use it for an SBOM format or anything else. If you just want to trade vulnerability information between multiple systems, CycloneDX can do that. But we also obviously can support, hey, is this component vulnerable to this particular vulnerability? So those are use cases we support as well as the ability to say, no, we've actually backported a fix for that vulnerability and we're not actually affected. Um, CycloneDX is extensible. There's multiple ways that you can extend CycloneDX, and we encourage a lot of innovation in that place. Some of those innovations actually make it back to the core specification as well.